Let me introduce you to my Warco drill press. But could it be improved? Welcome back to the workshop. So in this episode we'll be mainly focusing on getting the parts made for the height adjust mechanism that looks like this. So we've got a number of parts to make. There's the central shaft there, an outer housing, we've got to press some bearings into there. We've got to make the mounting plate as well, and a few other bits and pieces on there. And when it's finished, it should look like this. Welcome to episode 14. So those of you who are new to this video project, this is a video series of me converting my drill press, fixing a number of the issues that you have with all kind of drill presses like this. First of all, there was the speeds. I kept having to go up onto the ladder, change the belts at the top every time I wanted a new speed, so I wanted to do something about that. So it did have a single phase motor hanging out the back. I put a much more powerful 3-phase motor at the top, and then I made up this bracketry to hold it with some slots so I could just adjust the tension. Now, being a 3-phase motor, I've also got the ability to control the speed. I've got this potentiometer here, and that's wired up together with this control box into the control panel that's on the wall there. That runs the inverter, and I can get a range of speeds from that. Now, should I need any more speeds, I've got the ability to drop this onto a larger pulley here and a smaller pulley at the back to get more torque if I've got some really large drill bits or some difficult materials. You'll also notice I've screwed it to the wall, so there's one of these on the other side as well, so I've got two fore-aft ones and then this diagonal one here. That's given me quite a lot of rigidity now. I'm pretty pleased with that. The other feature you have on a lot of drill presses, or you usually find, is a very small amount of play between the quill and the bore inside here, and you end up with a very slight amount of movement. And the idea is there's a little groove in there and a little lock screw, a grub screw somewhere here that just locks into that, and periodically, so I've got it a little bit on the tight side now just to get it as good as it can be. I want to do something a little bit better than that, so there'll be a plate that comes around here and it will run off some linear rails I'll show you in a moment. So that's to give some pretty accurate positioning for the quill and just try and keep it in as straight a line as possible. So the other thing you notice on here is these two big box sections, which are pretty heavy duty. They tie into the frame at the top, or into the head at the top, and then they also tie back to the column via these 20mm plates in 3 places. That's to give a nice rigid mounting surface to a 6mm plate that goes on here. We'll have 20mm rails on here, 4 carriages at the bottom that hold the table that moves it up and down, and then 2 more at the top which form the rail system that holds the quill and allows that to move in a straight line as well. Now the idea of all that is that, I'm sure you've been in the same position as me, if you've got a small drill in here and you've got your workpiece on the regular table that clamps to this, and then you want to move the table down to put a larger drill in to carry on with that hole, or you want to tap a thread, you end up losing position because it just moves around the column. So by having an XY table that sits onto these rails, when you move it up and down, it should stay reasonably accurate, and if this is also on those same rails, hopefully they'll all stay roughly in line, or certainly good enough for what I intend to do with this. So you'll also see I've got this ball screw here, so we mounted that in the last episode. That moves the ball nut up and down, and the ball nut's attached by a big bracket, which we've yet to make. That goes onto the table, and we need some way of turning this. So the plan here is there'll be a plate that goes on here, 10mm thick, and have some slots in it, so we can get some adjustment on it. Into there we'll have a housing that's got some bearings on it, and then there'll be a shaft goes all the way through. There'll be a handle on this end, and then there's 2 bevel gears. So bevel gear on the end of this shaft here goes onto the bevel gear on here. So you'll turn the handle, you'll turn this, and that will move the table up and down. Now, a couple of things there. I could motorise it. I think I'm going to be okay. I think I'm not going to move it that far. A couple of turns and it will move 5mm per rotation, so that's not too bad. So within a few turns you move it up and down, probably within the range you'd want. One thing to watch out for here, I'll talk a little bit more about it later, probably in a future video, but the XY table together with the vise and the workpiece is going to end up being quite heavy, and on the linear rails it's going to want to move up and down quite easily. So you have to be careful you don't back drive this screw. Now there are some formulas looking at the angle, the pitch of that, the mass of this and the friction on the ball nut that tell you how heavy you can go before it's going to start to back drive. I think I'm pretty close to the limit, so we'll see how we go. and then we might have to put a counterweight on. There's a couple of options we can look at, but we'll worry about that a little bit later. So that's the basic idea, is just to try and overcome some of the limitations you often get in these drill presses. So we've got our variable speed motor at the top, so we don't have to keep changing the belts. We've got a kind of bearing system that holds the quill and keeps it in line, so we don't have to keep adjusting this all the time. And then the XY table moves up and down on rails, so when you go up and down you don't lose your reference position, and you can drill your pilot hole, lower it down, and then tap a hole or whatever you're doing. So I think next we need to focus on the drive system. There's a couple of jobs we could do on that, so I think what we'll do, we'll go over on the bench and have a look at the materials we've got and work out the order of operations. So as you can see, I've got some of the drawings laid out, some of the parts we need to make next for the drive mechanism. I'll just also talk about this. This has come in, this is our 6mm tooling plate. This goes right in the front of the machine. You can see it's 6mm thick there. And this is where the rails will go. So the rails will go down both sides, our linear rails, and then there's a slot in here for the ball nut to stick through to drive the table, and a few other features in it as well. And it'll have some levelling features, some little grub screws in it, just so we can get that nice and true to the axis of the quill. But what I think I need to do is work on the parts behind this first and put this on a little bit later. So we'll put this to one side and then we'll talk about the other parts. So if we start in this corner here, this is the block that will pick up the ball nut assembly, so that goes into there. And then this end here, this screws into the XY table to move it up and down. And the stock we got from that is this really big solid piece of aluminium. So there's quite a few operations here. One is to square the block up and then bring it down to the dimensions. So we'll do that on the CNC machine. Then we'll also pilot out these holes and drill and tap them. And then for this bore here, we haven't got enough travel or enough length on the tool to go all the way through. So we'll just pocket it probably about 10mm, leave maybe 1mm on the material on the radius on the outside here. And then we'll get it set up on the 4-jaw, dial that in so it's concentric, and then we can bring the bore out to the final size and take it all the way through. Then the only other one is just to get this radius feature and get this pocket machined here. As you can see, that's 23mm deep, so we'll come in, imagine this is the way we'll come in from this side, and we only really got 20mm of tool there. We'll just stick it out the collet a little bit more and just see if we can get that last bit of feature in there. And then this is the axle that drives the ball screw up and down. So this is the part where the handle goes on this end. It's got a keyway. Now the handles come in. So that's here. I had a look around different handles, and you can get cast ones. The nicely finished cast ones are pretty expensive. I did find a really cheap one, but it's really poorly finished. I thought I could true it up and make it look nice on the lathe, but it's all time. And I thought, well, actually, what we'll do, I think it's about £8. This is like that plastic, like a kind of phenolic type stuff. And then it's moulded with that insert in there, and then the keyway in there. We'll see. For about £8 or £9, see how it holds up. It's all plastic. If it breaks, I'll get really fed up with it. Then okay, we'll go for the metal one, or I might even make my own. But I've made my own enough of my own parts in this project. I think we need to speed up a bit. So that's what I've got for the handle. And then just here, it still stays at 12mm, and that's the journal for the bearings to run on. These are just regular shielded bearings. I've got a pack of 10. Not very expensive. I've had a feel of them, they feel okay. For what I need, I think that'll be okay. So that'll go on there. There'll be one on the other end. And then this one, I have got this keyway. What I think I'm going to do actually, because I think I'm going to just use set screws at 90 degrees. So these are the bevel gears I've got in mind. This is what I used on my differential for the go-kart. Pretty pleased with them. Not that expensive. So I've just got a pilot bore, I need to open that out. And then we'll put our two grub screws in at 90 degrees. Drop that on there, and then that will turn the motion 90 degrees. So one's on the ball screw and one's on here. Now I've also got this, just in case. This is actually a set from, again, very cheap, from an angle grinder. I forget which make it was, it didn't really matter. And the idea was that in case it was a bit slow to move the ball screw up and down, I could also drop this gear on. So this would be the handle side and this would be ball screw side, just to give a bit more speed. And I could also make that work as well, which is why, as we'll see in a minute, there's some adjustability on the mesh and engagement, so I have the option to fit both. But at the moment, I think I'm just going to go with that single set there. So that's the drive axle for the control mechanism. And then this is the main housing that holds that shaft. So we've got bearings in each end. Now at this end, it'll be a press fit with Loctite, so that won't really come out unless you destroy the bearings. That's our solid fit, and then the shaft will go into there up to that shoulder and bolted on with the handle, so that will be very rigid and won't be able to move axially. But at this end we've got a much looser fit, just a general light press fit, probably with my fingers, or just a gentle tap with a hammer into there, and a light press fit on the shaft into there as well. That's so I can assemble and disassemble this whole piece in and out, and just leave that press fit bearing in there. That's like our master, if you like, and everything else can come in and out and be disassembled relatively easily. Now I was thinking about making that out of aluminium, but because of these press fits and that thin wall, I thought better off we go with steel. So I've got this bright steel. This is EN3B, so it's a much better quality than normal mild steel, and I've got about 300 mil of that. I mean, mostly you pay for postage when you order this stuff, so you may as well order a bit extra. So we got that, and that's our housing that the shaft will run through in the bearings, and then the handle goes on that end there, and the bevel goes on this side, bevel gear system here. And then the piece I just showed you over there is a press fit into there, into this 10mm thick plate, and then it's got these two slots that allows it to move up and down on the machine. I've got this 90 degrees, but it moves up and down, and that's to vary the mesh. That's in case I want to go for just a 1-to-1 bevel gear, or want the large to small. I could change my mind depending on how I want it to be driven. I'll see what it feels like. Now, slight concern here, the only thing holding this in is this tight press fit of that outer tube assembly there is pressed into here. I did think about putting threads on the outside, very large, making my own threads, own nut, and putting something on there, but I think we'll get away with it. I think if we make that tight enough fit, that should be okay and not work loose. Now to make this shaft here, I've got this bit of steel out of some industrial equipment, so it's probably a fairly good grade. There's plenty on it, and we'll use that to machine that. So I was going to make the ball nut holder, I think I mentioned last time. I don't know, I'm in kind of a lathe mood, so let's get going with this and get started. So it's the usual operations here, just faced off the end, then drilled and put a centre in. I had the part sticking out quite a long way from the chuck, but I thought I could probably do that all in one operation, at least keep it concentric. Then we're turning down the end that holds the journal on. So this needed to be a general sliding fit, so I could assemble it by hand and take it in and out a few times to adjust it if necessary. I didn't want it to be a tight fit, a one fit deal. So now we're turning down the end to accept the 10mm threads. This is an N10 by 1.5, so it's a coarse pitch thread. And then the undercut for the thread to run out of. Here we're tapping the M10 by 1.5 thread. Then test fitting it with a nut. Yeah, that went okay. I don't use these very often, but for the other end I just broke out my left-handed tools. Very handy if you need to machine from left to right. Okay, we'll take this out, and then we've just got the keyway to do here. Okay, so this end we'll have our bearing on there, so it'll be our master reference bearing. Then we've got 10mm spacer, then the handle, washer, 10mm nylon nut to hold that in place. Then on this end, another bearing on, this will be the floating end, just find its own position. And then there'll be the keyway in here, 5mm keyway, and then the spur gear or bevel gear goes on the end of there. That'll be locked in place with 2 grub screws. There we go, there's our drive shaft. So there's all the lathe work finished on the main drive shaft. I've still got to put the keyways in both ends, one's for the handle and one's for the pinion. And while I was over at the lathe, I also made this, which is the main outer housing. So we've got our pockets here for the bearings at each end. I had to get out the steady rest to do those, just to give the extra rigidity. So I was quite a long way out the chuck. So that's the main housing finished. And while I was over at the lathe, I also made this little spacer. So it's flat on one side, there's a little feature on the other side, I'll show you why in a moment. And while I was over at the lathe, I also made this little part here. How did I do that? So we can have a little look at the assembly now. So I've got these bearings, these are very cheap, little 6001 with the metal seal on there. Got a pack of 10 of those for about £10, so £1 each. Can't really beat that, and they feel pretty smooth. Certainly I think they're going to be okay for this application. So we'll need 2 of those. So if we look at our drawing, so that's the driven end, the longer one, and the bearing needs to be pressed into there. So these are 28mm outer diameter, so I made this pocket 27.96 on this side, so that'll be a pretty nice press fit in there. The other side I wanted to be the other side I wanted it to be a bit of a sliding fix. This is the floating end, so this will just find its own position. So I think I made that 27.99, just a shade under 28, and you can see it with not much effort. That'll just tap in there. Oh yeah, I can even just push it in with my fingers, so that's fine, because I'll probably end up assembling it and disassembling this a few times just to check the fit of the pinion, make sure the keyway is going to be in about the right place and all that kind of stuff. So that's that. So we'll put this one in last because we probably won't get it out once it's in. So we'll leave the bearings for now. Actually, let's just try them on the main shaft. So yeah, so I'll be the bearing first. Should be a nice fit on there. Yep, to make it easy to assemble. Then so this will be pressed into the housing like that, and that's up against that shoulder there. So that'll go in there. Then we've got our spacer, and I deliberately put this little step in it. I think it's about 0.2mm, just to make sure, because I wanted to come out to the full diameter of this housing to just make it look a bit neater, just to make sure we definitely weren't rubbing on the outer part. They should be subtly under flush or about the same, but just in case, so that just gives us a little bit of a shoulder to push up against. So this will all be flush with the same height of this as this outer housing. And then the handle itself, it's just this fairly cheap handle I found. That's still 4mm keyway, so I need to revise my drawing from 5 down to 4. I thought it was going to be a 5mm, but that's okay. So that then goes on next. Let's just take the housing off for a minute. There, yeah, we should just have enough. Let's put our washer. And then this will be a nylock nut, or I've got another nut which is like a little domed one, which I think is the right thread. And that should just bring us to about flush. Yeah, it's pretty good. I didn't want anything sticking out. I might even just use that, trim it down a bit and put a bit of thread lock on it. So there we go. So that'll be our handle on that side. I'll go through there. That way. And then bearing on that side. This is quite a nice fit on the shaft. There we go. Whoop. And then there'll be our pinion. Got a pair of those bevel gears. They've all got to be machined out and cleaned up, but basically that'll go on there with the keyway and the grub screw. So there we go. So now we need to, I think what we'll do, we'll press this main bearing in, the master bearing, the reference bearing, because that'll stay in forever. And then, so let's just go and see what press tooling we've got to do that job. So I didn't have anything completely suitable, so I managed to find this little offcut, and then I just machined a little feature in there, just so it makes sure it press on the outer race, not on the inner race. So that fits quite nicely on there. There we go, and that will press that down nicely. There we go. This is just a little 2-ton arbor press. I think it will be enough. I haven't got anything better than this. I haven't got any hydraulic press or anything like that, so let's see how we get on. Got everything centralised. Just make sure I pick up on the outer race and it's all square. I think it's okay. Here we go. That feels okay. Push it home. Okay. looks good. Does it still spin? Yes. Nice. Right, now that's pressed in okay, let's just do another dry assembly just to make sure. So we won't put this lower bearing in yet because otherwise we won't get it apart again, or not easily. Yes, that's a nice fit in. Oh, there we go, nice fit in there. Then it was the spacer, that little feature towards the bearing. There we go, you see it's quite a nice flush finish. We've yet to put the 4mm key in there. See, I did also have a look at that. You see, you end up, where is it? You end up with a little bit of a gap there. And it's because if you look at the way they've made it, they've moulded that, and then it, you know, the metal inner sticks out slightly, and I don't want it to bear on the plastic, so I did think about putting a little pocket into that spacer there, just so that sit a little bit closer, but I think I don't want to risk it bearing on the plastic, so we'll just leave it. It's just a little bit annoying. That would have been nice to get that all flush. Could take a touch off, I guess, but I think we're okay. Right, so let's just see what we're going to do this end. So, okay, so on this end, I think what I'm going to do is just basically go with a washer, put a bit of thread lock on there, and then just tighten that up. I don't think it will come undone. Oh, yeah, it's a bit bulky. Maybe I could turn it down a bit on the lathe, but yeah, it's okay. I don't think it will want to come undone because most of the force is going to be transmitted through the keyway and through the shaft, and there's not really much vibration going on back here, so should be okay with just thread lock on there. And there we go. Feels good already. So I've yet to put the bearing in that end, but yeah. Runs nice and true as well. Oh, does it? That's not bad. Yeah, I think there's a bit of run out on the way they've made this. Not too bad though. Right, very pleased. Okay, for the next operation we need to press this onto there, and we've just got those two shoulders which are an interference fit into that bore, or hopefully they are. So let's just take that apart, see if we can get that on there. Okay, so you'll notice the way I've done it, we got those two shoulders there. That distance is 10mm, which is the same as the plate. And just to give somewhere for the material to go, just because that's going to be quite a long press there, I've just relieved it in the centre ever so slightly. I used the parting tool to do that, or grooving tool, and you can see it's ever so slightly chattered. I can't really get in there to clean it, but it'll be inside the bore, so that's okay, inside of that press fit. Right, let's see how we got on. So I think what will happen is these may slightly push apart into these channels, but there's plenty of clearance for the screws that go in here to still slide up and down for the adjustment. So I think we'll be okay, but it will push out ever so slightly. But we'll see how we go. So that's got to go in there. In fact, let's just take the shaft out. I haven't tried this yet, so hopefully the numbers add up. Yeah, it feels like that's going to be quite a nice tight press fit on there. I'm probably going to have to make some tooling to do this, to pick up on that. And then I'm only bearing on a small end there, but it should be okay. This is steel. Right, let's go and see what we got, and then get that pressed home. So before we do a press fit, I just want to check the dimensions we got on the outer part there and the dimensions we got on the inner part there. Now they're notionally 32mm, but there's this should be fractionally over and that should be fractionally under, just enough to give that nice fit. This is steel and this is aluminium, so just got to bear that in mind as well. Just dug out my measurement tools. Now the problem I got is these digital micrometers only go up to 25mm, so I can't measure that. The internal micrometer, which is great for doing internal bores. It only goes up to 30, and this is about 32. So I'm a little bit stuck. I can use calipers, but I'll be using these inner jaws, and these are not the best for trying to measure the diameter, but we'll see how we get on with that. And for the outer one there, again, I can use the caliper, and then I can double check just with the this manual micrometer here on the outside. So let's just see what we've got before we start pressing and the whole thing gets jammed and we can't get it off again. Alright, so let's start with this one. So there's two parts we're interested in, these slightly raised sections here, and there's a little bit of relief in the middle, so we just need to make sure we don't measure that. So on the rearmost one, we're at saying, if you can see it, just tilt it so you can see 3205 is about where we got to. Yeah, 32.05, so 0.05 larger. And on the front one, again tilting it a little bit so you can see. Yeah, 32.05, maybe 06. So about 0.05 larger on that. So let's go and check the inner bore on this. Actually, before we do that, we can double check that with the external micrometer here. Somewhere there. So 32.06. So 05 with the calipers, 06. Okay, so about 0.05, 0.06 larger. Right, let's check this bore. So the only tool I can use for this is the outside part of the digital calipers. So let's get myself some space. Across that part, we are you can see why this is not the best tool for this. Uh, 31.9596, so we're actually about nearly 0.1. That's quite a lot of interference. Right this way. 31.9596, yeah, so about 0.1 millimeters, which is a fair bit. Right, what I might do is just warm this up just to give us a little fighting chance. So we'll warm that up, get the press set up, and then we'll press it on. Fingers crossed. Right, so put that part on the press. We've got our little press tools made up. They'll go on there. And then the piece, you can probably hear the heater going. That's just warming up that part. We'll quickly drop that in and hopefully press that on. There we are, down to there. Okay, here we go. We'll go and get the part and we'll press it on. Let's go in. I think we're on. Are we square? That's what we've got. Nice tight fit all the way around there. Good, yeah, that's really good. The reason that needs to be such a good fit on there is because, how's it going to go? Yeah, this way. This will go onto the box section, so the handle will be this end, and that will be bolted through in 4 places. And you've got this big moment here, so when you're cranking this, effectively all those forces are going through that small contact area, so I didn't want it to kind of wiggle loose over time. That's the only thing kind of holding it in. And then the gears over here, so it's quite a big offset, but hopefully that'll do it. As you can probably see on there, wasn't really room in the design because of the box section is a given width, and I'd already committed to that in the design. And I had to, this was about the furthest I could get outboard with the bolts. And this was the bearing, which was the other limitation, so effectively I didn't have very much room to add, say, a threaded nut over here with a special bespoke nut or anything like that to try and clamp the whole thing together. So I went for a press fit in the end. Hopefully that'll do the job though. So let's go and offer that up and see what it looks like on the drill press. Before we do that, let's just put it together again then. So that's the main drive shaft. The spacer. Handle. We've yet to put the keyway in, obviously, but that'll go on there. And there. Washer and nut. Okay, now we haven't put the bearing in this side, although that is, yeah, that'll probably go with a light push. I can't get it out again, so we'll save that to the last operation. Alright, let's go and see what this looks like. It's starting to come together now. Come on. I think there's a bit of paint in the threads. Oh, there we go. Okay, doesn't need to be super tight because it's got to come off again. I'm going to do the bevel gears and put the bearing in the end. There we go. Get that one, yes. There we go. Oh, there's no bearing in the back here, so it's still a bit wobbly. Looks good, and it's adjustable so we can get the mesh right on the bevel gears over here. Very pleased so far, looking good. Yes, hopefully you can see, well, there's no bearing in the back there, so obviously it'll just wobble a bit, but when that's pressed home, you can see what's going to happen there. So there'll be 2 bevel gears. These still got to be machined and have grub screws put in and keyways and etc. So there'll be one on there and one on there, and then the adjustment there is so we can get the mesh correct, and then we can move it in and out that way on the shaft just to get it nicely centered onto, get the engagement correctly onto that gear. So there we go, looking really good and pleased with that. Okay, that's it for this video. I think I made pretty good progress there. I'm pretty pleased how it's turned out. It looks like it's going to work, driving these bevel gears. Off camera, just to note, I did actually end up machining this spacer down a bit. Just gave me a little bit more room here, and then the thread is flush with the end of the nut and it looks a little bit neater just through there. But that was just off camera, I didn't show that. So we've still got to get the bevel gears machined in here, the grub screws and the keyways, and there's a keyway still got to go in there to lock the handle onto the shaft. But we'll do that in the next video. Well, I hope you're enjoying the build series so far. It'd be great to hear from you in the comments section below, so leave me a comment there and I'll catch you next time.